Good day, grade 12s. I hope you are fantastic. Welcome back to another exam revision lesson with Mr. T. And as always, I'll be sharing my approach to grade 12 maths, and I really hope that this lesson will be relatable and beneficial to you. In today's lesson, we're going to be looking at the November 2022 DBE Mathematics exam, question 3. Let's begin. The first question reads as follows. It is given that the general term of a quadratic number pattern is Tn equals to n squared plus Bn plus 9, and the first term of the first difference is 7. Okay, just ignore the two firsts there. I'm just going to shade one, right? So like I said in the previous video, I usually read questions twice, and I do this because the first reading is just to familiarize myself with the question. The second one is to try and comprehend the question, okay, or the information that's provided to me. Now, I'm going to read it again. This time I'm reading to really, have an idea and perhaps to understand. Okay, so it says, it is given that the general term of a quadratic number pattern. This might seem very trivial, but it is very important. Okay, so I'm going to mark that. It's a quadratic number pattern. Okay, so already when they say that it's a quadratic number pattern, I start thinking of the tree diagram, just calculating the first and the second difference. I think of the general formula and everything that is included under the topic of the quadratic number pattern. Okay, so it is given that the general term of a quadratic number pattern is Tn equals to n squared plus Bn plus 9. Oh, another thing I forgot to mention is I'm also thinking about how to calculate the general formula. Okay, remember you have the three formulas that you use. 2a equals to the second difference, 3a plus b equals to the first term of the first difference, a plus b plus c is equals to the first term of the sequence, right? So as I'm reading here, all these ideas and concepts are playing in my mind. Okay, so I'm going to read it again. It is given that the general term of a quadratic number pattern is Tn equals to n squared plus Bn plus 9. Okay, so this is going to be let me reduce that. This is going to be our formula, and it further says, and the first term of the first difference is 7. Okay, now I'm just going to write the information down. Basically what they're saying with the last part is, here you have a sequence. Here's your sequence, right? And the first term of the first difference is 7, right? We don't know what the second term is, so that's going to be a question mark. We also don't know what the second difference is. Let me perhaps use question marks here. Question mark, okay? But we know for sure, we know this much, that the first term of the first difference is 7, okay? That is done. Now, the first question says, show that b is equal to 4, okay? Remember what I said. The minute they mentioned quadratic number pattern, I already began to think, okay, what are the, possible ideas or concepts I can use, right? Before I even read the questions, what are the possible ideas or concepts I can use to calculate my answers, right? Now, looking at this, they said show that b is equal to 4, right? Already, I know that, okay, with the information provided to me, I'm given the formula, which won't help me with much, right? But the second part of the information is exactly what I need to calculate the value of b. They said the first term of the first difference is 7, right? We know that the first term of the first difference is equal to 3a plus b, right? So we're going to use that to calculate this. So we're going to say our 3a plus b is equal to 7. However, we have a problem. We don't know the value of a, right? But the value of a is not that big of a deal. we have our general formula here, which should be an squared plus bn. The format is an squared plus bn plus c. And the formula that we are given, the general formula we are given, is Tn equals to n squared plus bn plus 9, right? What does this mean? This means A, since it's invisible over here, it's 1, right? Remember the invisible 1 rule. It's going to be 1. Our B is B as it's a question mark because that's what we're calculating for. Our C is going to be equal to positive 9, right? What do we need here to calculate for B? We need A. So we're going to say 3 open bracket 1 close bracket plus B equals to 7. This is going to give us 3 plus B equals to 7. We transpose the 3 to the other side. B is equal to 4. Right? And that's exactly what they asked you to prove. They said show that B is equal to 4. And we just did that. Okay? So, this is how you would work out this question. You just look at, it's always important, like I said, when you are provided with information, it doesn't matter which topic or question, right? Try to read it a minimum of at least twice, okay? So that you can, the first time you just, familiarize yourself with the information and what's provided and, the wording they used. And then the second time, you then read to understand, read to comprehend, so that now you can begin to identify, okay, there is a possibility of, or there's a chance that you might have to use the 7, right, in one of the questions that will follow, okay? But if you just read once, then you get into the question, you'll find that you struggle, a bit more than someone that would read the information like twice, 3 times, okay? So please take this as a tip from me to you. Read the information at least twice, okay? Now let's go to the next question. The next question reads as follows. Determine the value of the 60th term of this number pattern, okay? Determine the value of the 60th term of this number pattern. Now, before we do this question, let me just discuss 2 concepts, Tn and n, okay? What is Tn? Tn is the value of the term, okay? Value of the term. And n is the position of the term. So Tn is the value of the term and n is the position of the term. So let's make an example. If we have a pattern 2, 4, 6, 8, right? Let's take 4. Let's take this. So 4 would be the value of the term. So it would be the value of the term. Okay? And second, because 4 is the second term, right? Second would be the position. Okay? So when they say determine the value of the 60th term of this number pattern, it means that they've given you the position, right? 60th, first, 4th, 10th, all those suggest that you are given the n, you're given the position. You are looking for the value of the term, okay? So we're going to come back here and say, okay, we have calculated our B, so our formula is now complete. It's going to be n squared plus 4n plus 9. Then we can substitute the 60 here. But now when we write it down, we're going to say T60, okay, is equal to 60 squared plus 4, 60 plus 9. And then from here, you can then begin to calculate your answer. I'm just going to do it on my calculator quickly. we're going to have 60 squared plus 4 open bracket 60 plus 9. That gives us 3,849. So the 60th term of this number pattern is 3,849. Okay, so let's say they wanted you to calculate the position. How would they phrase the question, right? Let's use this. So they would say, which term is equal to 3,849? It means now they've given you the value of the term and they want you to calculate the position, right? Let me repeat it again. Which term of the sequence or which term of the pattern is equal to 3,849? That's how they would phrase the question, okay? But when they say determine the value of the 60th term or calculate the 4th term, they have given you that 4th is the position, right? They now want you to calculate what? The value of the term. All right, now let's proceed over to question 3. Question 3 reads as follows: determine the general term for the sequence of the first difference of the quadratic number pattern. Write your answer in the form TP equals to MP plus Q. Okay, I'm going to read it again because this is a long question, so I need to really absorb it and understand what it's asking for. It says determine the general term. Okay, they're looking for the general term for the sequence of the first difference, okay, of the quadratic number pattern, right? So now this is what they're saying. They're saying, okay, you've calculated the formula of the quadratic number pattern, right? It's there. Let's maybe write it here. Tn equals to n squared plus 4n plus 9. Now calculate the formula or the general formula of the first difference. Okay, remember the quadratic is the main sequence. The first difference is an arithmetic pattern. Okay, the first difference of a quadratic number pattern is always an arithmetic sequence. Okay, so what we're going to do is we will maybe calculate the first 3 terms of the quadratic so that we can do the constant difference or the 2 differences, the first and the second difference, and then from there we can calculate the general formula. Okay, so I'm going to start with T1, say 1 squared plus 4 plus 9. It's going to give us 1 plus 4, that's 5. It's going to give us 14. Then we can calculate T2, 2 squared plus 2 plus 9. It's going to give us, let me put it here in the calculator quickly. It's going to give us 21. T3 equals to, put 3 there, squared plus 3 plus 9. Let's put 3 there. This is going to give us 30. Okay, let's maybe also get T4. Okay, 4 squared plus 4 plus 9 is equal to 41. There we go. Then we can put these here: 14, 21, 30, 41, right? Then we calculate the differences. This here is going to give us 7. They've already given us that the difference, the first term of the first difference is 7. If you want, you can just verify it. It is 7. Then we proceed. 30 minus 21, it's going to give us 9. 41 minus 30 gives us 11. And then we can go to the second difference. 9 minus 7 gives us 2, and 11 minus 9 gives us 2. There we go. See? So now we have all this information. Remember, which pattern are we calculating? We are calculating the formula of this pattern over here, right? Now, what is the format of the general formula of an arithmetic sequence? It's Tn equals to a plus n minus 1 close bracket d. But they said we should write it in terms of Tp. So we're going to replace the n with p, have a plus p minus 1 close bracket d. Then we can substitute everything we need. What's the first term of the arithmetic sequence? It's going to be 7. Put 7 plus p minus 1 close bracket. Our difference is going to be 2. We multiply up the two brackets. It's going to give us 7 plus 2p minus 2. Then we'll have 2p plus 5. Right? 7 minus 2, that gives you 5. So our formula for the first difference is going to be 2p plus 5. Tp equals to 2p plus 5. Okay? I hope that is understandable. Let's now go to question 4, which will also be our last question. Right? Now, this one, I'm going to need you to pay attention. Okay? Listen very carefully here, because this question costs a lot of learners marks. Okay, and what's funny is it's actually a simple question. Okay, there's two methods. I'm only gonna do one, which I believe that it's quite simple. Okay, the other one, it's a bit long and the equation can be so big that you can easily make mistakes. Okay, with this one, it's very straightforward, but it's gonna need you to really listen. Okay, question 4 says, which two consecutive terms in the quadratic number pattern have a first difference of 157? Let's read it again. Okay, and highlight the important parts. Which two consecutive terms, very important, in the quadratic number pattern have a first difference of what? Of 157. So we are looking for two consecutive terms, right? Meaning terms that follow each other, right? Two consecutive terms that when we subtract, we get a difference of 157. Okay? Now, I'm going to take a detour before, I can start solving the question. Okay? So, let's maybe start here. If I have, these are the terms of my quadratic number pattern. Okay? Right? I'm now trying to, give you some context as to why I'm taking this approach, okay? Or why this approach makes sense. So if you have T1, T2, T3, T4, T5, remember these are the terms of the quadratic, right? When you subtract them, getting the first difference, right? When you subtract them, getting the first difference, what we will notice is, now I'm going to use small letter T because I can't use the capital letter T. It's going to look a bit weird. So when we subtract T2 by T1, what do we get? We get, okay, let me use capital letter. We get T1 of the first difference. Remember, this is the quadratic. The second difference is an arithmetic, okay? I'm doing this to avoid saying the first term of the first difference. So this is going to be the first term of the arithmetic. So if we say T3 minus T2, this gives us T2 of the arithmetic. T4 minus T3, this gives us T3 of the arithmetic. T5 minus T4, this will give us what? It will give us T4 of the arithmetic, right? Now I'm going to take perhaps the first two. So clearly when we say T2 minus T1, it gives us what? It gives us T1 of the arithmetic, right? And when we take T3 minus T2, what does it give us? It gives us T2 of the arithmetic, right? And it's like the same routine, okay, up until infinity, okay? So what do we then realize from here? We realize that when we subtract consecutive terms, right, the position of the smaller position matches with the position of the difference in the arithmetic or in the first difference. Okay, let me repeat that statement. When we subtract two consecutive terms, right? For example, T2 minus T1, right? The difference, the position of the difference in the first difference, right, is the same as the smaller position between the two consecutive terms. I'm not saying the value of the term, I'm saying position, okay? So the position of the difference in the first difference, it matches exactly with the smaller position between the two consecutive terms. So it means now, if I'm subtracting T99 by T98, right, my answer in the first difference will be in position T98 in the first difference. So if I'm subtracting T99 and T98 of the quadratic, or the 99th term and the 98th term of the quadratic number pattern, I'm going to get the 98th term of the first difference. I hope that makes sense. Okay, so it's very important for you to understand this. Okay, so in this case, they have said to us which two consecutive terms, meaning we don't know what those terms are, right? We don't know the positions. However, they gave us what? The value of that first difference, the value of the difference between them. Okay? So now, remember in the previous question, we calculated the formula of the first difference, which is basically an arithmetic sequence. We calculated the formula, the general formula of the first difference. We said it's what? TP equals to 2P plus 5, right? That's what we calculated. So now they have said to us, or they said to us, the value of the difference between these two consecutive terms that we are looking for, right, is 157, right? This 157 is a term in the first difference. So we're going to take the 157, put it here, equals to 2P plus 5, and then we can calculate for our P, transpose that to the other side. It's going to give us 2P equals to 152, divide both sides by 2. Let's see what we're going to get. 152 divided by 2 gives us 76. Therefore, our P equals 76. Now, you've calculated the value of, or the position of 157 in the first difference. It's the 76th term in the first difference. Now, what did we say? We said, okay, if the position of 157 is 76, what does it mean? It means that the two consecutive terms in the quadratic that were subtracted to get T76 of the first difference will be what? It will be T77 minus T76, because this is going to give you what? T76 of the first difference. Does it make sense? So when they say which two consecutive terms in the quadratic pattern have a first difference of 157, we'll say the answer is T77 and T76. There we go. However, you have to calculate. You don't have to include everything I've done here. You can just include this section. Perhaps this, I think. Yes. Right? There's an alternative method. I'll probably cover it in another video, but not this one. I hope that you've learned a lot from this discussion. And yeah, until I see you again, bye.